Okay, creating a requirements document. This is a major issue in software engineering because requirements are constantly changing and expanding, or if you're really smart, they're contracting. It's always better to remove requirements than to add new ones because you're more likely to actually meet your deadlines. What you'll need to do here is to create a requirements document. Now, this is a one-semester project. You probably don't want a big formal document. But what you want to do is to draw a box around what you're trying to build. In other words, look for the perimeter. Look for all the ways in which to say, this is exactly, anything we build is going to be within this box. We're not going to suddenly go wandering off into the field next door. So that you have a scope, and part of the idea here is to correctly convey what you're building to all your team members. Now, this is why it's so hard to write requirements. And it's why a lot of organizations will sort of like, oh, we don't need requirements, we'll just do sprints every week. And we're sort of building the direction. And often what that does is it ends up leading you down blind alleys and you have to go back anyway. First problem is you often require that before you know or fully know what you want to build. The more inventive the thing you're building, the more likely this is to happen. It's like, oh my gosh, I've got this great idea for a game. It's X. Okay, and then actually a few of you who are doing games have said, yeah, we're sort of doing this. And we haven't quite figured out what we're going to do after, beyond that. And with games, speaking from personal experience, this is difficult because you have to figure out what's actually fun and entertaining instead of simply tedious and overly simplistic. Now, back to Armor. You'll hear me quote Armor almost every single class lecture. You write that before you're sure you can build it. And again, the more novel your new project is, that is, the more different it is from anything that you have currently built or that exists and that you fully understand, the more likely it is that there's going to be some unexpected invention in there, which means it's going to seriously impact your schedule and your requirements. The wrong people are often involved in writing them. Managers who don't understand what's feasible in the time build. How many of you have had that experience? See a lot of hands here. Anyone want to share a few examples of managers saying, we're going to do X, and you try to tell them, no, we don't have time to do X. Anyone have that kind of experience? Yeah.
We just had this, we were planning out our sprint, and the manager said, all right, how many points do you think this would be? And all of us were like 20 plus. And they thought they would be like maybe 3 or 4 points, or something like that. And they're like, what? And then we explained our reasoning. And thankfully we had a really good manager, so they're like, okay, we're going to take it back and see if they want to invest 20 points into this.
Yeah. Other feedback on this particular item? Anyone have more stories they want to share? Change names, think guilty. Engineers are often interested in building something cool and something that people will pay for. This is a more subtle and pervasive issue than you may think, and it's difficult because sometimes it's building the cool thing that generates customers. As an engineer, you have this idea, this nifty idea, and it's sort of, if I build it, they will come. And sometimes that happens. And a lot of times it doesn't. The 70 years of IT is filled with the history of products that someone, manager and/or engineers, thought would be really cool, and no one paid any money for it. Or very few people did. And of course, marketers who want the impossible. It's a dessert and a floor wax. You have the problem that customers usually don't know what they want until they see something. This is one of the key things that motivated the entire Agile manifesto. Get in front of customers early. As I said, I think last week, one of our lessons at Pages is that beta testers are not end users. Beta testers tend to drink the Kool-Aid. It's cool, they're part of your team, they're giving you feedback, they've already bought into the concept, and then you set this in front of the ordinary user and they say, what the heck is this? This isn't what I wanted. I want Emacs keybindings. Yeah. General simple requirements, now this is another key point. General simple requirements explode into a large number of detailed design and implementation requirements. You need to be very aware of this. Your requirement may be, okay, it gives me a 3D picture of my character that I can rotate. Now, assuming you don't have a 3D modeler that will do all that for you, it's kind of like, okay, what do I really need to do that? Well, I'm basically developing a whole 3D physiological model, starting all the way from flipping, hidden surface elimination to, how do I make things look realistic? How do I avoid truly atrocious looking 3D characters, so on and so forth. Failure to formally manage requirements can lead to massive scope creep. This is a lot of the driver behind Agile and DevOps, with the idea that rather than having a rigorous change control process to say if you're adding a requirement, it has to be approved by so many people, you make the changes so small and incremental that it can be done in a week or with your DevOps operation in a day, in an hour. And then you can quickly back it out if you need to. How many of you on social media, and I see this as someone who uses Facebook, will see something suddenly change in the user interface, often breaking something, and then see it backed out that same day or a day later. I've had that happen a number of times. And someone said, oh, we're going to make this change, it's going to be so cool, and it breaks a whole bunch of stuff. Oh, we're backing this out. Actually, when we read Accelerate, they'll talk about high performance in an organization includes the ability to back out undesired changes quickly. There are strengths and weaknesses of Waterfall versus Agile. My little 2 cents I'll give you is that a Waterfall-ish approach gives you the time to think through the problem set well and to come up with a solid architecture. The problem is you can spend all your time doing analysis. Analysis paralysis is a term that's been around for decades. Because they never quite stabilize on a set of requirements. Like just code at some point. Agile avoids that by saying, build a little, design a little, build a little, test a little. Tight spiral. The problem with Agile that I've seen is actually a fundamental architectural problem, which is because you are not thinking through the entire problem set up front, you can often get a local maximum as far as an ideal solution and get stuck there when there's actually a much better general solution off some distance. In other words, you run to a local maximum if it's a 3D model. Imagine a plane with peaks of varying sizes. The higher the peak, the better the solution. And often with Agile is you'll run to the nearest peak, whether or not it's the best solution. And you'll get to the top and you get stuck there until you somehow figure out you're going to have to go all the way down, undo stuff, and start looking around for other peaks. When we did Pages, this was a design-oriented software, design-oriented desktop publishing software. And the idea was that you had these design models that you could load in, and it would immediately relay out the document according to that design model. And it would always be well laid out in terms of the elements and how they were placed on the page, and the font kerning, and the paragraph spacing, and so on and so forth. And the founders of the company were a world-known typographer, Mike Parker. You can go look up his entering Wikipedia. And Vic Spindler, who was a very successful graphic designer out of New York. And they'd had this idea for a long time and finally came up with some funding, and that's how they funded Pages, so we got venture funding. Anyway, and Vic had a couple of design models, pretty good business standard design models. And this is early days when it was pretty much me. And I was trying to do the architecture of this, and I said, Vic, I said, you've got these two design models, which are different. This design, I forget what the names were, but here's A and B. They're different, but they're not that different. And I said, I need a design model that you consider within the scope of Pages, but is as different as possible from these two. And he came up with one called April that followed design elements from a famous graphic designer named April Brand. And if the two we had were there, April was sort of down here. So in doing my architecture, I had to design an architecture that could encompass all three of these. Whereas if I just had these two, my architecture would have just looked like that. I spent 2 or 3 years swearing in April Brand because I'm doing architecture, trying to get something to work, and it's like, okay, headlines and subheads, these work fine. And then in April Bryman, they had circular headlines that were on one side of the column, and the text had to flow around it. And it would change sides depending on the page layout. But what ended up is we had a very, very robust and generalized architecture. And I've mentioned to you, I think I've mentioned to you that when the web stuff came out in late '94, we said, hey, let's make this a web page editor. And we did it in like 4 months. And the reason we could do it that fast was that the architecture had everything in place. Even though we hadn't done anything with HTML, we didn't know anything about the web really until late '94. It only took us 4 months because we had this very powerful general architecture that was very easy to adapt to web pages. Okay, approaches to requirements. First, your requirement document should be your baseline of what you want to build. I've mentioned getting called into ARING, my first consulting job at ARING, Aeronautical Radio. They're the ones doing the network management software for their Iridium satellite project. And the same time I started there as a consulting architect, Bob Millar from Motorola came in to try and get them back on schedule. And Bob and I worked very closely together for about 3 months, and it was a tremendous professional education for me. Very first meeting, Bob Miller asked them, where's your requirements? Where's your baseline documents defining what you're trying to build? And the people there in ARINC all looked sort of confused, and they had a few diagrams and binders. He said, no. I said, I'm going to be here once a week from Arizona. He said, I'm not going to be happy until there is a box or a stack of binders sitting on this table for a meeting that defines exactly what you are and are not building. And he said, if you don't know what you're building, how do you know when you're done? That's a problem a lot of projects face. They never define when they're going to stop building. Dr. Knudson's podcast on software requirements is good. It's important not to define what you are not building. Again, at Pages, we were doing this desktop publishing thing. We finally closed on venture funding after about a year and a half. Hired our permanent full-time CEO, Larry Spellhog, who came over from Xerox, where he had been the product manager for Xerox Ventura Publisher, which is their desktop publishing system. And one of the things he immediately required that we do, we as a development team, and actually as a whole company, built a spreadsheet of basically every possible feature you could put into a word processor or desktop publishing system. It was 600 plus features. And then we went through and ranked them as far as, here are the features that have to be in version 1.0 pages. Here are the features which we may build into a subsequent version of pages. And here are the features which we will never put into pages. That was a tremendous guideline, because anytime an issue came up as far as our development process, we could go to the spreadsheet and say, is this a 1.0 feature? If not, drop it. Don't do any work on it. Focus on the other stuff. And as we went along, a lot of 1.0 features moved into post 1.0 status. That was us dropping features. So, you've got, oh, I'm sorry, I left the old dates up there. Okay. It's not December 10th and November 12th. That's what I get for copying my slides. Let's look at the dates here.
March 18th and April 15th.
Thank you. In that case, I will go right back to here. Editing requirements on the fly. March 18th?
Yep.
And April 15th. That would be. Oh, the way around. So, what you want to do this week as a team, as you're doing your requirement, and it's going to require some serious communications among you. Define what you're going to build, what you're not going to build, and specifically what you want to demonstrate in March and in April. And I tell you, for most of you, as the semester goes along, stuff that you list as you want to demonstrate in March will get pushed off to April. Stuff you list for April will simply get pushed off to the end of the year. So this is a document that should be maintained current and up to date, because this is one of the ways in which you communicate among yourselves as a team. One of the complaints I get past semesters is that you guys often don't talk to each other a lot. I know some of you have set up private Slack channels. I would recommend all of you as teams set up private Slack channels. Talk to each other, make sure people know what's going on. Don't go dark. That's another big complaint. Sort of like we had so-and-so on our team, and after about such a date, we just never heard from her or him again. Don't do that. If I get that feedback, that will impact your grade. So, for this week, I actually have the date right there. So, yes, I have both the dates right there. So, the first draft says, I will basically say, I don't expect this to be a final draft, but your first cut at your requirements document, defining what you're building, what you want by March, what you want by April, what you're not building, should be on the wiki by midnight Saturday. And then we'll review them in class. These I may bring up one at a time in class in 2 weeks. I may not, because we're going to be pressed for time. I'll see how much time we've got in 2 weeks. But at the very least, I'll look at all of them. And if I have questions, I'll give you feedback and so on. Okay, I've told you before, now we'll hear it again, this is relatively easy. Okay? If you as a team produce what I consider to be a generally acceptable requirements document, everyone gets full credit. Okay? That's how the team requirements work. So, and the point here is I want to see the exercise. I want to see you go through a mental exercise of trying to negotiate what you're trying to build in your teams. More than saying, oh, well, you didn't follow this format for you to do this. Now, I have criticized teams in the past because I get the requirements documents like, okay, this is way too lightweight. I need to see a little more detail in this. It's one of the reasons I introduced the 2 demos. a month before the end of class on the last day of class, because that gives you something specific to define in your requirements document. Any questions on any of this? Okay, let me change videos here. We'll go to the